Bismillahirrahmanirrahim. In our 10th lecture of our course Digital Electronics, we will study the decoders and the encoders. Now we are starting our topic from the decoders. Here, decoder is a multi-input and multi-output logic circuit which decodes n inputs into 2 raised to power n outputs. As we have A and B, 2 inputs, so 2 raised to power n means 2 raised to power 2 is equal to 4 outputs. We will write the output as O3, O2, like output 3, output 2, output 1 and output 0. These are 0, 0, 0, 1, 1, 0, 1, 1. These are our inputs and we will draw the output as on 0, 0. We will have output 0 is 1. On 0, 1, the output 1 is 1. On 1, 0, output 2 will be 1. And on 1, 1, output 3 will be 1. And the other values of the output will be 0. This is how we draw the decoder. We put the values in the truth table of the decoder. You can draw it as A and B, the inputs, the decoder, the 2-bit decoder as we have in the value 2, the 2-bit decoder, and the outputs are 4, 2 raised to power n outputs. Now to draw the circuit diagram, we will take the O0 value which says A bar, B bar, A is 0, B is 0. For output 1 we have A 0 but B is 1, so A bar, B. For output 2 we have A but B is 0, so B bar, and for output 3 we have A and B. Now we will draw the circuit diagram for it. We will take the A and we will take the B. For A bar B we have the NOT gate. They are connected with the AND gate. And we have A bar and B bar, and by connecting with the AND gate A bar B, that is output 0. Now on the same method we will draw the output 1 which says A bar but B not the B bar, and with AND gate we have A bar B, this is output 1, and for the output 2 we have A and the B bar connected with the AND gate, output 2, and for the output 3 we have A and we have B connected with the AND gate, that is output 3. This is our circuit diagram for decoder, and this is our truth table for the decoders. Now we will see that this is for the 2 bits, and if we have to draw for the 3 bits, like if we have 3 inputs and the 8 outputs, how we will draw that decoder. Okay, now we will see the 3-bit decoder. That is A, B, C, 3 inputs. 2, 3, 2 raised to power n. So the outputs will be 8. 3 inputs and 8 outputs. So as we write for the 2-bit, on the same method we will write for the 3 bits. 07, 06, 05, 04, output 3, output 2, output 1 and output 0. Like this we have the 8 outputs and the 3 inputs. 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. Now we will have to put the outputs, and we will put the output on the same method as we did for the 2-bit. Like we have to put the 1 on its way, we have to draw the 1, 1, 1, and for the output 5, 1, for the output 0, output 1, output 2, output 3, and output 4, then for the output 5, then for the output 6, and then for the output 7. We have to write the 1 like this, and all the other values will be 0, 0, 0, 0. Like you can put all the zeros. And now we will draw the circuit diagram, and to draw the circuit diagram we should know the logical expression. So for output 0 the logical expression is A bar, B bar, C bar. For output 1 we have A bar, B bar, C. Output 2, output 3, output 4, 5, 6 and 7. Total 8 outputs. So for the output 2 we have A bar, B, C bar. Like you can see the output 2, here is the 1. So we have A bar, B, C bar. This is how I am putting the values. So A bar, B, C, A, B bar, C bar. For the output 5 we have A, B bar, C. For output 6 we have A, B, C bar. For output 7 we have A, B, C. Now we will draw the circuit diagram for it, which says like we have to take the A, then the A bar, the B and the B bar, and same as C and the C bar, and they all are connected with the AND gate. A, B bar, C bar. This is our output 0. In the same method we will draw the other outputs. A bar, B bar and the C. We will have the output 1. This is output 0. Like now we will draw the output 2, which says A bar, B, C bar. We will take the A bar, the B bar, not the B bar, this is B. We will take the B and the C bar and connect with the AND gate output 2. On the same method you have to draw the all outputs. Like you will take the if we have A bar, you have to take A bar, the wire from the A bar, then the B, and for the C bar you will take the wire from the C bar, and for the B you have to take before the NOT gate the B1, not the B bar, and connect them with the AND gate, as there is the AND gate in between. This is the symbol of the AND gate, and you will get your result, the output 1, 2, 3 or whatever it is. Now we will study the encoders. Okay, the encoder is a digital circuit that performs an inverse operation of a decoder. It has 2 N input lines and N output lines. It is the opposite of the decoder. The second thing is we have the 2 N inputs and the output will be N. Like if we have 2 raised to power 4 inputs, the output will be, if we have 2 raised to power 2 inputs, like 4 inputs, the output will be 2. we can draw it as the 4 inputs of the decoder: D0, D1, D2 and the D3. But there will be the 2 outputs. It is our encoder and the output will be A and B. It will be the opposite of the decoders. So now we have to draw a truth table which says that A and B 0, 0, 0, 1, 1, 0, 1, 1. Now we will write the 1 on the same method as we did before this, and the all other values will be 0. Now to draw its circuit diagram, we have to write it as A is equal to the value of A and the value of B. Now we will put its values as, we have the 1, this one of the A and this one of the B. And on these values we have 1 in D2 and D3. So its answer is D2 plus D3. Now for the B we have this one and this one. On this value where we have 1, it's on D1, and for this one we have 1 on D3 plus D3. These are the values for A and B. Now we have the inputs D1, D2, D3. The only inputs which are getting involved in our expression, D1 and D3 are connected by the OR gate. This is D1 plus D3. This is B for the B, and now for the A we have D2 connected with the OR gate, D2 plus D3. Okay, this is the circuit diagram. This was our truth table, and this was our decoder. As we draw it for the 4 inputs and the 2 outputs, we can also draw it with the 8 inputs and the 3 outputs, the opposite of the decoder.